For decades, Pluto held a special place in our hearts. It was the ninth planet in our solar system. Discovered in 1930, it quickly became a favorite. Kids learned about it in school. It was the little planet at the edge of our cosmic neighborhood. Pluto was small and far away, but it was one of us. It completed our family of planets.
But science doesn't stand still. As we learned more about our solar system, questions arose. Was Pluto really like the other planets? It was much smaller than we thought at first. Its orbit was different too. It didn't quite fit in with the other planets.
Then came 2006. That year changed everything for Pluto. Scientists met to talk about planets. They had to decide what makes a planet a planet. New objects were being found in space. Some were like Pluto.
The decision shocked many people. Pluto was no longer a planet.
In August 2006, astronomers from around the world gathered. They met in Prague for the International Astronomical Union Conference. Their goal? To define what makes a planet a planet. This might sound simple, but it wasn't. The solar system is complex. New discoveries were challenging old ideas.
The IAU came up with three main rules. These rules would decide if an object is a planet. First, it must orbit the sun. Second, it must have enough mass to be nearly round. Third, it must clear other objects from its orbit.
These new rules changed everything. Suddenly, Pluto didn't make the cut. It met the first two criteria, but it failed the third. Pluto shares its orbit with other objects.
The reclassification wasn't just about Pluto. It affected how we see our whole solar system. It created a new category: dwarf planets.
The first rule for being a planet is simple. It must orbit the sun. This means it travels around our star in a regular path. Pluto does this. It has been circling the sun since it formed. This is why Pluto was considered a planet for so long. It's in our solar system, just like Earth or Mars.
Pluto's orbit is different from other planets, though. It's more elliptical or oval-shaped. Sometimes Pluto is closer to the sun than Neptune. Most of the time, it's farther away. This unusual orbit was one reason scientists started to question Pluto's status.
Orbiting the sun is important. It's what makes an object part of our solar system. Pluto easily passes this test. Section 4, Criterion 2, nearly round shape. The second rule for planethood is about shape. A planet must have enough mass to become nearly round. This happens because of gravity. When an object is big enough, its own gravity pulls it into a sphere. Pluto meets this criterion too. It's not perfectly round, but it's close enough. This rule is important. It separates planets from smaller space rocks. Asteroids, for example, are often irregular in shape. They're not big enough for their gravity to make them round. Pluto, despite being small, has enough mass to be almost spherical.
Pluto's roundness tells us something about its history. It means Pluto probably formed like other planets. Meeting this second criterion puts Pluto in good company.
Section 5, Criterion 3, Clearing the neighborhood. The third rule is where Pluto stumbles. To be a planet, an object must clear its orbital path. This means it should be the dominant object in its orbit. It should have enough gravity to push away or absorb smaller objects. Pluto fails this test. Its orbit is crowded with other objects. Pluto lives in a region called the Kuiper Belt. This is a ring of icy bodies beyond Neptune. Pluto is one of the largest objects here, but it's not alone. It shares its orbit with many other Kuiper Belt objects. Some are quite large, like the dwarf planet Eris.
This rule caused the most debate. Some scientists argue it's not fair to Pluto, but there's a big difference. Section 6. The impact and importance of reclassification. The reclassification of Pluto was more than just changing a label. It changed how we see our solar system. It showed that our cosmic neighborhood is more complex than we thought. We now know about many objects beyond Neptune. Some are like Pluto. This new view expands our understanding of space.
This change also shows how science works. Science is always ready to update its ideas. When we learn new things, we sometimes have to change old beliefs. This can be hard. Many people were upset about Pluto's new status. But this is how we make progress. We adjust our views based on new evidence.
The Pluto story teaches us about categories in science. Categories help us organize what we know. But nature doesn't always fit neatly into our boxes. The dwarf planet category helps us describe objects like Pluto.
Reclassifying Pluto has sparked new interest in the outer solar system. Scientists are now studying the Kuiper belt more closely.